Hello and welcome to another video on algebraic proof, and in this video we're going to be looking at quadratics. So let's look at this first statement. It says n is a positive integer. Prove algebraically that the quantity n plus 2, all of that squared, minus n squared is always a multiple of 4. Now before we prove this algebraically, let's just use an example with an integer. So let's pick the number 5. Okay, we could pick any positive integer, but I'll just choose the number 5 because it's nice and small. So what we're going to do is, wherever we see an n, we put a 5. So this is going to be 5 plus 2, all of that squared, minus 5 squared. And apparently, this is always going to be a multiple of 4. So let's work it out. So 5 plus 2 is 7. So this is going to be 7 squared, which is 49, minus 5 squared is 25. And 49 minus 25 is 24. Now, is 24 a multiple of 4? Yes, it is. It is 6 times 4. So it works for 5, and apparently it works for any positive integer. So our job is to prove that using algebra. Now, the first thing I'm going to do is I'm going to expand these brackets. So n plus 2 squared, that does not mean n squared plus 2 squared. So n plus 2 squared is just n plus 2 times n plus 2. Now there's a couple of ways you could expand this. You could use the FOIL technique, or you might want to use the grid method. And I prefer the grid method, so I'm going to use that method. So we've got n plus 2 multiplied by n plus 2. So I'm going to multiply each term in this bracket by each term in this bracket. So I should have 4 terms when I finish. So n times n, that gives me n squared. N times positive 2 is positive 2n. Positive 2 times n is again positive 2n. And then 2 times 2 is positive 4. So we've got n squared plus 2n squared plus 2n squared plus 4, which we can simplify. That all becomes n squared plus these two terms here. 2n plus 2n is 4n. And then plus 4. So this whole thing in brackets here becomes this. I've just expanded the brackets, and now we're just going to add on minus n squared to the end. Minus n squared. Now we've got this expression, we can simplify, we can collect like terms. So we've got an n squared, take away n squared. What is n squared take away n squared? Well, that is nothing. They cancel out with one another. So all we are left with is 4n plus 4. That is all we're left with. Now, is this a multiple of 4? Well, this is definitely a multiple of 4. So just to prove that, we can factor out a 4. We can divide both terms by 4. So if we factor out a 4 from our expression, 4n divided by 4 is just n. And then plus 4 divided by 4 is 1. Now, we have proved that this is always a multiple of 4 because it doesn't matter what is in these brackets here. As soon as we multiply by 4, it becomes a multiple of 4. So that is our proof. Okay, so why don't you have a go now? What I'd like you to do is pause the video and see if you can prove that this expression here, algebraically, is always a multiple of 8. And just a hint to get you started is to expand the brackets. Okay, so let's give this a go. So 4n plus 1 squared, again, we can rewrite that. So when we multiply these two expressions together, again, I'm going to use the FOIL method. So 4n times 4n, that gives us 16n squared. 4n times 1 is positive 4n. 4n times 1 again is positive 4n. And then 1 times 1 is positive 1. So when we simplify this, we have 16n squared. And then we've got plus 8n. We can combine these terms together. Plus 8n and then plus 1. And then at the end there, we've just got a minus 1 as well, which we need to tag on. So how can we simplify this? Well, we can see that the plus 1, minus 1, those two terms just cancel out with each other. So all we're left with is 16n squared plus 8n. And now to prove that this is always a multiple of 8, we can factor out an 8. So if we factor out an 8 from both terms, we're left with 2n squared. 8 times 2n squared is 16x squared, and then plus 1. And again, because we factored out an 8, whatever we've got in here, we are multiplying by 8. Therefore, by definition, that is going to be a multiple of 8. Okay, I'm going to go through another couple of questions. This one is going to be an example that I do because it's slightly different to the previous two, and then you can have a go yourself with this one. So this question here, prove algebraically that this expression here is always an odd number. So again, the first thing to do is expand these brackets. So this means 4n plus 3 times 4n plus 3. And again, I'm going to use the grid method to expand these two brackets. So 4n times 4n is 16n squared. 4n times 3 is 12n. 4n times 3, again, that is 12n. And 3 times 3 is 9. So what do we have? We've got 16n squared. And then these two terms add to get 24n. And then we've got plus 9 on the end. So we've expanded these two brackets. Now let's have a look at this. So here we can just expand this bracket. So we're going to have 2 times n, which is plus 2n. And then 2 times 1, which is 2. So this is our expression now. Now we can simplify this. We've still got 16n squared. But if we look at our n terms, we've now got 26n plus 26n. And then 9 plus 2 is 11. Now we've fully simplified this. Now we have to prove that this is always an odd number. How can we prove that this is always an odd number? Well, the trick that we're going to do is we are just going to focus on this part of our expression, and we're going to factor out a 2. So let me just show you this. So if we factor out a 2 from this part of our expression, we are left with 8n squared and then plus 13n, and then we've just got that plus 11 tagging onto the n there. Now, hopefully you can see that whatever we put in this brackets here, whatever value for n we put in here, we are multiplying by 2. So this whole part here is going to be even. Doesn't matter what value you put for n, we're going to get an even number here. So this is always even because we're multiplying by 2. So if this is even, now we're going to add on an odd number. Now this whole expression, that is going to be odd. Because if we have an even and we add an odd, we always get an odd number. So we have proved that this expression is always odd. So it's your turn now. Using a similar technique, try to prove that this expression is never a multiple of 3. Okay, so the first thing to do is let's expand these brackets. So n times n is n squared, n times 1 is n, 2 times n is 2n, and 2 times 1 is 2. So let's rewrite this now. We've got n squared, and then we've got plus 3n, and then plus 2, and then finally we've got minus n squared. Now we can simplify this. N squared minus n squared, those two terms cancel out, so all we are left with is 3n plus 2. Now, is this a multiple of 3? Well, no, this is definitely not a multiple of 3. How do we know that? Well, this is a multiple of 3, and then we're adding on 2. So this whole thing is 2 more than a multiple of 3. So hopefully you found that useful, and I'm going to do one more video on algebraic proof. But this time, instead of having our quadratic expressions written out for us, we are going to construct them ourselves. See you then.